Hello, my dear students. I hope you are very well. After we have revised the four arithmetic operations, the basic four arithmetic operations, addition and multiplication and subtraction, today we will discuss together a very important and interesting concept in math. It's called exponents. So, our lesson about exponents. To be more specifically, we will discuss the integer exponents, but here I will write just exponent. Now, what I mean by exponent? Let me ask myself this question because there is no anyone here, just I'm talking with myself in front of the camera. So I will ask myself here, a power n or exponent to n. What I mean a to power n? What does it mean? What's that it mean? It's mean a times a times a times a. How many times? N times. Here. So, if we have a symbol, a letter, anything, any number, this A is represent a number. This is called a base, by the way. It's called a base. This one is called exponent. The answer of them, A to power n, the answer of them as a one block is called power. It's called power. Okay. So the base A power n is equal A times A times A n times. Let me give some examples. Example number one. Easy example. If I ask you 2 to the power 3 is equal to what? Is equal 2 times 2 times 2. How many times? 3 times. 2 times 2 times 2, which equal to what? 2 times 2, which equal to 4. 4 times 2, which equal to 8. That's my answer. Another one. Assume it is negative 2 to the power 3. Now, the answer is what? Negative 2. All of them to the power 3. The answer is what? Very important questions. Here. Negative 2 to the power 3. Now the 3 here is exponent to what? To 2, not to negative sign here. So I will leave the negative sign as the final step. So 2 to the power 3, I have found it here. In the previous question, it was 8. So the final answer must be negative 8. Let me analyze this. So this means negative, I will put the negative here. And the priority for the exponent, that we will discuss later, inshallah. We will discuss later in the next lesson the priority of operations in real numbers. But now, in this stage, so 2 to the power 3 is equal to 2 times 2 times 2, as I said, which equal to 8. So the answer is must negative 8. But here, we have a bracket or parentheses as you want. Here we have a bracket to power to what? To 3. So the answer is negative 2 times negative 2 times negative 2. See? Negative 2 times negative 2 times negative 2. How many times? 3 times. Why 3? Because the exponent is 3. Now the answer, as we learned previously in the previous lesson, by multiplication of sign number or integer number, here negative times negative is positive, then times negative, the answer, final answer must be negative. Now, I have found it is 8. So the final answer is negative 8. Good. Up to now, everything is good. So, you can replace this 2. I give 2 as a simple case. I choose 2 as a natural number. You can put anything you want, any number you want. Assume as a fraction, 2 over 3. to power 3, for example, it must be equal to what? 2 over 3 times 2 over 3 times 2 over 3. If you want to find it, as we learned previously also, 2 times 2 times 2, 3 times, it will be 8 over 3 times 3 times 3, which equal 27. That's good. Now, let me go to the next case, our next rule. I will erase this out. Now, the more interesting thing here in exponents, it is rules, it is properties. There is many properties help us to solving any mathematical equation or any mathematical problem we face. So, look to me learn what's the rules of the exponent and what we can do with the exponents. Okay, I will mention the rule here on the right hand side, and I will give the example here on the left hand side. So, the first rule I will say a to power n multiplied by another a with the power m. So the answer is what? If the base are equal here, if the base is similar, now we have a rule say the answer is a, still a, but add the exponent a to power n plus m. This is the first rule I want to mention. Let me give some examples here. 2 to power 3 multiplied by 2 to power 4, which equal 2 directly 3 plus 4, which equal 7. And find the final answer, which is 2 to the power 3, which equal to 8, 2 to the power 4, which equals 16, 8 times 2, which equals 16, yeah? Now, the final answer is 8 times 3, which equals 80, 8 times 6, which equals 48, 48 plus 80, which equals 128. Now, let me continue. Another example. This case, we face it more when we discuss together an algebra or a polynomials, the degree of polynomial. You will discuss that, inshallah, maybe in chapter 3 or chapter 4. So, I will give you as a brief step here. Assume we have x to the power n. What's the problem here? X make it 2 times, I will use this notion. I will not use the simple this one. X to the power 6. So x to the power 2 times x to the power 6. The final answer is x to the power 8. So we need to add the exponent here to find the answer. So if we want to multiply two powers, have the same base, different exponent, just so we need to add the exponent. That's the first rule I want to discuss. Okay. Note that I didn't give any example up to now have a negative signs here in the exponents, because there is another rule here. I want to mention it later. Okay. Second rule. In division, what we will do in division, assume we have a to power n divided by a to power m. You have the freedom to use any division symbol you want. A to power n as a fraction, or the usual division sign, this sign. But here I prefer this form. A to power n over a to power m, which equal a to power n minus n. What I mean by this? I mean by this, if the base are similar, if the base are equal, so we can subtract the exponents here. Subtraction the exponent of the divisor from the dependent. That's what I want to make sure you understand. Let me give example here. Example 2 over 3. Let me put power 4 here and power 6 here. So the answer is 2 over 3. Now, if you want to apply this, form, we can't. Why we can't? Because here the base are different. Look, this base is 2, this base is 3. So we cannot apply my rule. So I need to convert this to 3 or this to 2. I will choose this to convert it to 2. Now I can apply my formula here, my rule, and we can say 2 to power 4 minus 6, which equal 2 to power negative 2. That's good up to now. But what 2 to power negative 2 equals? We have learned that a to power n equal a times a times a n times. But what's meaning? The negative exponent. What's the meaning of the negative exponent? The negative exponents here, that's what I want to explain now. Negative exponent, if we have a as an integer number, and we have a negative exponent here, negative n, that means I will deal with the reciprocal of a, or the multiplicative inverse of a, which is 1 over a to power n. So the negative sign, it means the multiplicative inverse of a. So here, if I say 2 to power negative 2, it means the multiplicative of the multiplicative inverse, or the reciprocal of 2, how many times? 2 times. So the reciprocal of 2, which equal half to power 2. So half to power 2, which equal half times half, which equal half times half, which equal 1/4. Good. So, to convert the exponent from negative to positive, just you need to take the reciprocal of the denominator here, the exponent of the base. Now, let me give another example. Assume we have a fraction 3 over 2 to power negative 3. So the answer is, because we deal with a negative exponent here, we need to convert it to positive exponent. But how? That's easy. By taking the reciprocal of the base. The reciprocal of the base. The reciprocal of the base is 2 over 3. Now you can convert the sign from negative to positive. So now it's become a positive sign, positive exponent. Now we can complete my problem here. So it will be 2 over 3 times 2 over 3 times 2 over 3, which equal 8 over 27, as I found it before. Good. Here. Another example. What's the bit? Assume we have 3 over 2 square, I want to mention that the exponent 2, a to power 2, because it's usually we use it very much, so it's used is denoted by a squared. A to power 3, a cubed. Let me give another example here. Simplify. This is the common questions on this concept. So simplify the expression says 3 to power negative 2 multiplies by 2 to power 2 squared. Make 2 squared here over 2 to power 4 multiplied by 3. How I can simplify it? Step by step, how we can simplify it. Okay, let me start. To simplify this, first step I will use these rules to help me. How we can use it, how we can, these rules give me the help. Now, take the bases which take the powers must have the same base here. So we have 2 and this is 2 as a base 2. So we can combine them together here 2 to power 2 over 2 to power 4 now times 3 to power negative 2 over 3. Okay. Now we can apply this formula. So the division, the exponent in division case, we can subtract them. So this is equal 2 to power 2 minus 4 times 3 to power negative 2 negative 1. Because I didn't write any exponent here, it means 1. Now, the final answer it must be 2 to power negative 2 times 3 to power negative 3. But this is not the final answer. What's the final answer of this? We need to find the final answer. So we will go directly for this case, for this rule, which says to find the negative exponent, we need to deal with the reciprocal of the base. The reciprocal of the base is, the first base is 2. So the reciprocal is half to power 2 times 1 over 3 to power 3. So finally, 1 over 2 times 1 over 2, which equal 1 over 4, times 1 over 3 times 1 over 3 times 1 over 3. So 1 times itself 3 times, and 3 times itself 3 times. So we will get 1 over 27. So finally, 1 times 1, which equal to 1. 4 times 27, 4 times 20, which equal 80. 4 times 7, which equal 56. 56 plus 80, so 136. By mental math. Okay? 4 times 20, which equal 80. 4 times 7, which equal 28. Sorry. 28, so 28 plus 80, so 108. That's final answer. Okay? Okay. After we have finished this example, I will give you more examples, many practice here, as a worksheet, inshallah. I need to complete our rules, so I need to mention the fourth rule here. For a to power 0, what this means? By default, there is no mean to a times itself 0 times. That's not help us. Here I said a to power n equal, as you know, before I erase the board, a to power n is equal a times a n times. So if I replace n here, I substitute n here as a 0. So there is no meaning to put a to power 0 is equal to what? So the standard case, a to power 0 is always 1. A to power 0 is equal to 1. So this, our rule, is a very basic rule. We need to learn it. That means a to power 0 is equal to 1, because there is no meaning to multiply a by itself 0 times. That's not happens. Okay, so I can give an example here. I think it's clear so put any number you want, 2.34, for example, anything to power 0, so the answer is 1. Not important with the base, because the exponent is 0, so the answer is 1. Good. That's what your lesson focuses. So that's our rules. That's what we need to deal later, inshallah, by algebra and the how we can solve polynomials and quadratic equation, or something like linear equation or more than. Okay. Up to now, I almost finished my class today. I hope everything is clear. Please don't try to ask me. Don't try to contact me in any time, by any way, by the phone, by text message, by WhatsApp, by email, by anything you want. Please ask what you want. If there is anything you cannot understand it, please ask me anytime. Okay. Before I finish, before I stop recording here, I want to remind you, every class we have here as a recorded video, you have a homework. You need to solve a homework. You need to practice. You need to make more practice, because you know the math, you cannot learn math if you don't make a practice. Okay, so please make practice at your home. Give me without ask you directly the questions of the lessons in every class, in every lesson. The question end of the lesson is a homework. Without I will mention that again. Every lesson we will take, you have a homework which is the questions in the end of the lesson. Every lesson in your textbook. Okay. Thank you very much. I hope you're interested in the video. I hope see you very soon in the classroom. Goodbye.